tend to think of the world map as, well, fixed, right? But what if I told you the face of our planet is constantly changing, driven by this deep, slow rhythm that plays out over hundreds of millions of years? We're going to take a journey through deep time to see the ghosts of continents that came before and the truly strange new worlds our planet might one day become.
So let's just jump right in with a pretty mind-bending question. If we could hit fast forward and leap 250 million years into the future, what would our home even look like? Well, geologists have a few ideas, and they are absolutely spectacular. Okay, so one of the big theories leads to a world called Pangaea Ultima. That name probably rings a bell, right? It's a callback to the last supercontinent. But in this future, the Atlantic Ocean, which is getting wider right now, does a complete 180 and starts closing up again. But what if the Atlantic just keeps on opening? Well, that could lead us down a totally different path, to a world called Novopangaea. In that scenario, all the continents just keep drifting, eventually smashing together on the other side of the planet to form a completely new supercontinent. Then you've got a third, even more dramatic option, a supercontinent called Aurica. This one would happen if both the Atlantic and the Pacific Oceans started closing down at the same time, basically pulling all the land on Earth together into a new central mass. And finally, there's a fourth possibility, where the continents all just drift north, gathering at the top of the world to form Amasia. So 4 completely different destinies for our planet. But how is any of this even possible? It all comes down to a kind of planetary dance. To understand where we're going, we first have to get a handle on this fundamental rhythm of our planet, the supercontinent cycle.
And just look at the timescale we're dealing with here. We're talking about periods of 500 to 600 million years. It's almost impossible to wrap your head around. But over these immense stretches of time, Earth's continents are basically doing this slow motion ballet. They drift together, form one giant landmass, and then eventually they tear themselves apart and drift away again. The world we see today, it's just a snapshot, one brief moment in this ancient repeating cycle.
And the engine that's driving this whole massive continental shuffle is something called the Wilson cycle. And here's the kicker. It's not really about the continents at all. It's about the oceans between them, because every single ocean has a life cycle, a birth, a life, and eventually a death. And you can see how it works right here. It all starts when continents begin to pull apart. A brand new ocean is born, and it gets wider and wider for millions of years. That's the phase the Atlantic is in right now. But eventually, that whole process can slam into reverse. The heavy ocean floor starts to slide under the lighter continents in a process called subduction. Think of it like a giant geological conveyor belt folding back under itself. The ocean shrinks and shrinks until finally, slam. The continents on either side collide, buckling up to form massive mountain ranges. This cycle, right here, is the key to everything. So how do we know any of this is true? Well, because this isn't just some wild theory about the future. We can see the evidence of this cycle everywhere in Earth's past. It's happened over and over and over again. The world we live on is literally built on the ghosts of lost continents. I think a lot of us learned about the supercontinent Pangaea in school, right? But just like this person on Reddit realized, Pangaea wasn't the first. It wasn't even the second. It was just the most recent celebrity in a very long line of supercontinents. The geologic record gives us this absolutely stunning timeline of these lost worlds. I mean, we're talking about Valbara, which might have existed over 3.6 billion years ago. Billion. Then came Kenorland, Columbia, and Rodinia, each one dominating the planet for hundreds of millions of years before breaking apart. And all of this happened long before the famous Pangaea ever came together. And take a look at this. This isn't some artist's drawing of an alien planet. This is a scientific reconstruction of Earth during the time of Rodinia, over 1 billion years ago. The chunks of rock that would one day become North America, Australia, Antarctica, they're all locked together in this totally unfamiliar puzzle. This is one of our planet's old faces. Okay, so now that we've looked back in time, let's jump back to the future. Now that we get this cycle, we can really dig into how those 4 different destinies, Pangaea Ultima, Novopangaea, Aurica, and Amasia, could actually happen. It all really boils down to one huge question. Which ocean is going to close next? Geologists have a few models for this. There's introversion, where the younger internal ocean, so the Atlantic, closes up. It's like everyone coming back together where the last party was. Then there's extroversion, where the older, bigger ocean, the Pacific, closes, pulling everyone together on the complete opposite side of the world. And finally, orthoversion, where the continents just kind of drift north and gather around the pole. So you see, each of those 4 futures we mentioned at the start lines up perfectly with one of these models.
Pangaea Ultima is the introversion model, the Atlantic closes. Novopangaea is extroversion, the Pacific closes. Amasia is the orthoversion model, where everyone meets up north. And Aurica, well, that's a wild combination of a couple of things happening at once.
Let's just zoom in on one of these for a second. Pangaea Ultima. In this world, the Atlantic spreading reverses. North and South America slowly, inevitably crunch back into Africa and Europe. And right down the middle, where they collide, boom! A new mountain range, probably rivaling the Himalayas, forms in the heart of this new world, trapping a small sea inside a colossal landmass.
But hey, this isn't just about redrawing the map. The formation of a supercontinent would fundamentally change everything about our planet, from the tides in the oceans to the very air we breathe.
Okay, first up, the tides. You might not think about it, but the size and shape of our ocean basins have a huge effect on how powerful the tides are. And it turns out, as the continents move, they drive what scientists call a super-tidal cycle. Right now, the Atlantic is shaped almost perfectly for big tides, but that's just a temporary thing.
And the changes can be absolutely extreme. In some simulations of Pangaea Ultima forming, scientists found a point where both the closing Atlantic and the shrinking Pacific would hit a kind of resonance at the same time. The total tidal energy on the planet could spike to 215% of what it is today. I mean, can you even imagine what the coastlines of that world would look like? The climate, too, would become a world of extremes. Today, our scattered continents mean we have tons of coastline, which helps spread moisture around and keeps temperatures pretty moderate. But a supercontinent? It would have a vast, dry interior with brutally hot summers and freezing cold winters, a much, much harsher place to live. And this cycle is linked to some of the most dramatic climate events in Earth's entire history. There's growing evidence that the breakup of the supercontinent Rodinia might have actually triggered the Snowball Earth events, these periods when our whole planet was basically a giant ball of ice. That's how profound the impact of this cycle really is. So, the ground beneath our feet is not static. It's on a slow but truly epic journey. The world we know is just one chapter in this ancient story, born from the breakup of the last great continent, Pangaea. The only real question is, what face will our planet wear next?